So up until this point, we've basically created an AI agent that allows us to do basic RAG prompting. We've demonstrated selective reasoning, and we've also demonstrated emergent capabilities in that our AI agent had multiple skills that were published. However, the capabilities that the end user was able to get from those skills that were published was far more than what the actual skills produce. So there are some problems with embedding selective reasoning directly into your application. For one thing, you have to deal with repetition, so you'd have to solve for that in some way. As of right now, as defined in the diagrams, we have a model, and then there's a boundary between that, and then over here we have our application. And within our application, we have the REPL loop. And then we also have a local agent where we have some selective reasoning in place. This agent exposes a bunch of capabilities that when the REPL loop makes the call to the model uses these capabilities as a whole, and then whatever it uses, so this is 2, this is 1, whatever it uses is sent back in some format that packages everything together. Now, the problem with that is when we get into additional applications. Because all of our logic is locked here inside of this application, if I were to create another app, let's say this is actually a mobile application of some kind, and maybe another app, which let's say is some kind of personal assistant device. That code that we have in here would have to be in some way, shape, or form replicated here and also replicated here. So there's a little bit of an issue there, and you have to solve for that in some way. And one way that you solve for that, for example, might be to have some kind of service endpoint. And for example, you might have all this logic inside of here, okay? And then everybody actually calls into this guy to be able to gather information. And that solves the problem for you locally. And introduces a whole bunch of other issues that we won't get into. Basically, you're now managing this brokering service. So you're managing the APIs, you're tracking all that stuff, and you're doing it in a very proprietary way. And on top of that, this API structure that you have here, while it works internal to your enterprise and everybody understands how to use it, if you're now going to try to connect it to the open web, right, then any provider, let's say you have an Alexa here, which is not inside of your network, and you have maybe a Ring camera here, okay, they have to have some kind of understanding of what is going on inside of your infrastructure. They have to understand the APIs that you have here. They have to understand how to access them. They have to understand how to deal with them. And you yourself on the back end have to now start coming up with a standards approach on how to expose your APIs and deal with all the issues associated with managing APIs, modern day service-oriented issues associated with managing APIs. So how can we solve for that, and how does this technology provide for a way to solve for it? So this very idea is what MCP solves for. And what we're going to do in the next section is create a Blazor application which is basically a web-based .NET application. We're gonna add the jokes XML to it. We're gonna add some MCP tool code to tell jokes based on these local files, and we're gonna test it all out. Now, as we're doing this, one thing that I do want to stress is that we're going to consolidate some of this stuff into a shared library so that we're not repeating code in every single place. So we still want to be able to call our regular console application, but then we're also going to be exposing an MCP version of what we're all the capabilities we have in a console application so that they can be shared more generally with whomever wants to use it. Let's get started. So we're right back to where we started before. We have our agent, the Just Jokes agent, which does all kinds of cool things. And what we are going to do now is take some of the functionality that exists inside this agent and expose it in a library that we can call to basically do the things that the agent does. So we're going to create a new library application. Okay, the next thing we're going to do is we're going to basically start copying the code over from here and pasting it. Okay, so I've added this capability and I haven't changed anything. Um, I've just copied it over, and I'm not using any of the Zarya functionality. So all this does is just return the current date as a string, return the current time as a string. Next, we need to take the tell a joke functionality and do the same thing. So we basically move it here and convert it into just returning a string. And here we have that converted over, and it's doing the same thing. And we're going to actually go back to pulling this jokes file like this. As a matter of fact, what I'm going to do is I'm going to pass the jokes path. And then over here, I'm going to pull the jokes path. And so what this allows it to do is based on the caller and based on how you're calling it, you can, for example, in a web application, it's probably going to be in www root, whereas in a console application, it may be wherever it's located. And finally, I'm going to take the weather, um, get weather method and do the same thing. Basically, bring it over here, make it static, and remove all the skill response related things from it. So that's copied over, and it's essentially the same. I'm returning the daily weather here. And basically that's being passed back. I deserialize inside and I just pass it back as the daily weather object. And that's what's going to get used within the application. So if we go back to the funny agent, you'll notice that some weird things are happening now. If you recall, I removed all those helper types from here and I added them to the funny agent library. So to be able to use them, I need to add a project reference to that library. And then I need to basically add the namespace. And with that done, everything goes away and it goes back to normal. It can see everything. Next, I'm going to go through and change all these behaviors so that they basically use the corresponding behavior inside of the agent helper. And I'm just removing the comments because those comments are now generalized, and whoever calls these comments will be created. So my agent is now pretty simplified. I'm basically just making a call to this funny agent library, and that's taking care of everything. The only place where there might be something gnarly, I suppose, would be in this agent helper tell a joke, whereby in this case, because again I'm running from Visual Studio .NET, the full version, and I'm running using the debugger. The debugger is using a file that's inside of the bin debug net10. It's like a pretty deep layer where the file is located. So if you're looking to reference the jokes file, you're going to have to walk back up to uh, the root of funny agent to basically be able to get it. And that's what this does. But I've set it up and set up tell a joke so that the caller gets to decide where this jokes file is located. So we're going to test this out now and just do some tests on the on weather to see if we get all the results that we expect back. So we're checking the weather tomorrow. Well, we see how cold it was yesterday. And finally, maybe we can do a prediction of what will happen in the weekend. And as you can see, it's once it picks the date, calls get date the first time, it now has it in context, so it doesn't need it for all subsequent future calls. So we're going to be adding now a Blazor web application. And the reason we're adding that is that we're going to be using this to host our MCP server. MCP comes as both a technology that can be hosted over STD.io or over HTTP. In this particular case, we're going to be hosting it over HTTP. You'll see that I've unchecked the HTTPS button. We really don't need that. So with that created, the next thing that we want to do is we want to add a reference to the library that we just created. This allows for the capabilities that we previously used to be still used here, so we don't have to create anything from scratch. Next, we want to go in and we want to copy the jokes file that we're using to pull the jokes from, and we want to basically move it over to our dub root folder so that it's available to our web application to use. We can then add a reference to the two NuGet packages that we're going to be using, which are Model Context Protocol and Model Context Protocol.ASP.NET Core. Note that they are both in preview, so just keep that in mind. For the purpose of this demonstration, they should be fine, but they are in preview, so they are subject to change. So we're quickly going to convert this over, first of all, to the main method version of the program, and then we're going to add a using statement for the library that has all the actual MCP capabilities. And then with that done, we now want to go in and we want to enable MCP. And you can do that by saying add MCP server. We want to make sure that we're using the HTTP version, not the IO version. So you can see we're going to say with HTTP transport. And then we also want to say that we want to use tools that have been discovered inside of this assembly. So we're going to say with tools from assembly. Okay, now the next thing that we need to do, and is relatively straightforward, is for the app, we basically say map MCP, and then we're going to provide basically the path where we want MCP to be located, and it's just going to be //MCP. That should be fine. Okay, so with that done, now the next step is for us to basically create the class that will serve as our host for all the MCP tools and services that we're going to be publishing. And for you to declare something as an MCP tool, you basically have to decorate it with a delegate. This is different from the Zarya approach where you extend a class. In this case, you are going to have to make it a MCP tool type, MCP server tool type, I should say. And then with that done, we just basically need to add all the methods that we are going to be exposing. And unlike what we've previously used, they're not going to be they don't respond to skill response, and they don't return a skill response, and they don't have a skill attribute on them. And of course, over here, if you recall previously, we talked about the different paths that you could use for actually pulling out the where the jokes is located. And of course, we're going to have to change the jokes path. So what we now want to do is decorate these methods with the appropriate attributes for MCP, which would be MCP server tool. And then we then use the description as mentioned before as a way to actually describe the reason why an AI should make a call to this specific method. A description can be found in system.component model. Then we're just going to copy the same description that we found inside of tool. As a matter of fact, I'm going to just take the whole thing and just start pasting it. All right, so we've got our MCP server set up and running now. So how do we actually test it out? So in order to test it out, we're going to be using Visual Studio Code, and we're going to follow these steps here where basically we open up a VS Code folder, we add a file to it called mcp.json, we then run our ASP.NET application, we copy the URL from our MCP server into VS Code as part of like registering this MCP server. Once that's done, we're going to be able to open up our Copilot panel inside of Visual Studio, and we're actually going to be able to select that tool as a tool that we want to use. And with that in the context of Visual Studio Code, we will then actually be able to test it out, call it, and do all these things. So let's walk through that and see how that all works. So in order to test this out, we first open up our Visual Studio Code environment, and we're actually going to open a folder here. And it doesn't matter where you open the folder. I'm actually going to do it in desktop as an example. Just call it test funny agent. Then we select this folder and that gets created. The next thing we want to do is we just want to add a folder here that we're going to call .vscode. And then inside of this folder, we're going to add a file that we're going to call mcp.json. And as you can see, once we add that file, it has this button that says add server. And adding the server is basically connecting to the MCP server that we just created. And of course, to use the MCP server that we just created, we're going to actually have to run it. So let's go ahead and let's run it. And we can copy this URL right here. And then going back here, I just click on add server. I want the HTTP version of this. I can enter my URL and remember that the MCP server is inside of /MCP. And I can give it a name, and I'm just going to call it funny MCP agent. And there we go. That's created, and we now have funny MCP agent. With that set up, you can now just start this if it's not already running. I'm actually going to restart it. Okay, and see here it says discovered 4 tools. And if we go in here, you see that there's calls to tools.list, which essentially returns the tools associated with this particular agent. And so that's all set up. So I'm going to close this for a second now, and maybe even close this. So with that set up now, you can click in here for this configure tools. And you should see here your funny MCP agent is in here. And when I click in here, I can see that each of the tools that I previously created are here. Get current date, get current time, get weather, tell a joke. So let's see how each of these work. So now within Visual Studio, with only the MCP setup, I can basically ask what day is it? And you'll see that when you make a call in here, there is some security that pops up, and you do have to allow it to run. So it's saying here, run get current gate, and I can get current date, and I can either allow or disallow. So I'm going to allow that. And so once you click that, it's going to say today is Tuesday, January 21st, 2026. Next, we can ask what time is it? And you'll see it'll do the same thing. Allow. And it's giving me the time of 10:33:06 p.m., which is correct. Next, we might want to know a joke. So tell me a joke. And as you can see, it's now going back to the funny MCP server. And when we click allow, um, what do you call a magic dog? Labra cadabra. And let's just quickly check here to make sure that that is one of the jokes. So here you go. What do you call a magic dog? Labra cadabra. So that's where it's coming from. And then finally, what is the weather like tomorrow? And here we go. It's come in here. There's still nothing showing up here because it's in a different console. But notice that the date has been specified. It knows the date that's being passed in. So that's coming from our call to get date that's happening somewhere else. Now, when I click on allow, it's going to just give you the time zone tomorrow in New York. Expect a cold day with highs of 7.2, right, and what have you. So our MCP server has not only been set up, but we've now tested it, and it's also expressed and shown emergent behavior, just like how we saw it when we were running it as a local agent. Now that we're running it as a tool that's part of our funny MCP server.